In this video, we take a look at adaptive sampling, sample clamping, and filtering. Let's go to the render settings and go to the sampling section. If you recall, we talked about adaptive sampling in the GPU rendering video a few lessons back, and honestly, that's the only time I use adaptive sampling in my own workflow. By default, we get a fixed number of camera samples per pixel. By enabling adaptive sampling, we make that process flexible or adaptive, so the pixels that show a greater variation or noise in their sample values will get higher camera samples per pixel. Right now, the camera samples is set to 3. Without adaptive sampling, all the pixels will get exactly the same amount of samples per pixel, which in this case is 3 by 3, 9 samples. Let's enable adaptive sampling. Now we have this AA or camera samples max value. In this case, we have defined a min camera samples, which is 3, and a max camera samples, which is by default 20. A minimum samples a pixel can get is 3, and the maximum is 20. If a pixel has a lot of variations in its subpixels, it gets a higher camera samples. And if it's a simpler pixel with a lot of similar values in the subpixels, it will get a lower sampling rate. What determines the sensitivity of adaptive sampler to noise is this adaptive threshold value. The lower the threshold, the more pixels will get higher sampling rates. I mentioned that pixels that have more variation or noise in their subpixel values will get higher sampling rates. What determines that noise or variation amount is the adaptive threshold value. The higher the value, the less sensitive it will be towards variations and noise, and therefore lower sampling rates per pixel will be used, and the lower the value, the more sensitive it will be to noise, and therefore more pixels will get the higher sampling rates. For example, let me set the camera samples to 2 and all the other samples to 1 and disable adaptive sampling. And basically see the render. Now, as you can see, the render is done in like 2 seconds. It's very noisy because it uses only 2 camera samples per pixel. Let's take a snapshot. Now, for adaptive sampling to work, you need at least 2 camera samples. I'm gonna enable adaptive sampling. The max camera samples is set to 20 by default. And let me increase the adaptive threshold to 0.5. Again, as you can see, a very quick render done in like 2-3 seconds. I'm going to take a snapshot again and compare it to the previous render. So even though we have enabled adaptive sampling, but because the adaptive threshold is so high, therefore a lower sampling rate is used for most of the pixels. We get almost the same results as the previous render, and both of these renders only took a few seconds. But if I decrease adaptive threshold to something acceptable like 0.01 or 0.015, now the render took much longer, but because the adaptive threshold is much lower, most pixels will get a higher sampling rate, and therefore we get a much cleaner render. Unless you have a very localized area that needs much higher sampling rate compared to the rest of your scene, you don't need to use adaptive sampling. Obviously, for GPU rendering, you have to use it to get some adaptivity in your render, as we learned in the GPU rendering lesson. For now, let's disable adaptive sampling and set the other sampling counts to default. Let's enable progressive refinement in the render settings and progressive render in the IPR. Now let's quickly discuss sample clamping. You can enable clamp sample values, which allows for clamping pixel samples to certain maximum values that you define down here in the AA sample clamp and indirect sample clamp parameters. The clamping is especially useful when you have fireflies in your scene. Fireflies are when you have very bright pixels here and there in your render due to a very bright HDRI image, or when you are dealing with volumetrics in conjunction with very small and bright light sources. For example, if I set the AA sample clamp to 0.5, Now, any sample that returns a value higher than 0.5 will be clamped. Obviously, I'm using a very small value for demonstration purposes. For example, a normal range of 4 pixel values will be between 0 to 1. A very bright pixel that shows something like a firefly would have a much greater value, maybe like 10, 20, or even higher. So we can keep the AA sample clamp at higher values like 5 or even 10 to get rid of the fireflies but keep the dynamic range of our render. So let's set it to 10 for now. Indirect sample clamp specifically is the threshold to clamp away fireflies from indirect light samples and reduce noise. If I set it to something like 0.25 again, you see the indirect values will get clamped, and this works similar to AA sample clamp but preserves specular highlights from direct lighting. Lower values result in more aggressive noise reduction, possibly at the expense of dynamic range. For now, let's set it back to 10. And we have this affect AOVs, whether clamping is going to affect different AOVs or just the main beauty render. Let's disable clamping for now. We have different filtering algorithms for sampling process. It's a long list here. Basically, a filter averages individual subpixels into a final pixel color. Solid Angle recommends using Gaussian or Black Harris filter. You have filter width. By increasing it, you are getting softer and blurrier results, but you should see less aliasing issues. At the same time, increasing it would cause the loss of detail because the render would get blurrier. If you want to have sharper final renders, you can decrease this value slightly, maybe to 1.9, 1.8. And if you reduce the width value too much, it would be like having no filter at all, which may give you a very sharp render, but you would have severe aliasing issues. Normally 2 would be a great value to use with the Gaussian filter type. And you remember when you use the toon shader, you need to use the contour filter type. So in this video, we learned about adaptive sampling, sample clamping, and filtering. See you in the next video.